USB-C was supposed to end cable chaos. One small, reversible plug. One port for phones, laptops, tablets, headphones, monitors, cameras, and chargers. It sounded like the simplest upgrade in consumer technology. But then people discovered the strange truth. Two USB-C cables can look identical and behave completely differently. One cable may only charge a phone slowly. Another may power a laptop. Another may transfer data at high speed. Another may connect a 4K monitor. Another may support Thunderbolt. And from the outside, they can all look like the same little oval connector. That is why USB-C feels so frustrating. The port is simple. To understand the confusion, we have to go back to the original dream of USB. Universal Serial Bus was meant to replace a mess of old connectors. Printers, keyboards, cameras, mice, drives, and accessories could all use a more standard connection. For a while, that felt like progress. Good. But USB kept evolving. Speeds changed, names changed, connectors changed. USB said 2, USB super speed. USB said das 3x1 Gen 1. USAB's 3x1 Gen 2. USAB's 3x3 2x2. US4. The average buyer did not stand a chance. The standard became powerful, but the language became a maze. Then USB-C arrived and seemed to fix everything. The connector was reversible. It was small. It could charge devices. It could move data. It could carry video. It could replace older ports. That was the magic, but it was also the problem. Because when one port can do almost everything, you have to ask a new question. Which version of everything does this cable actually support? The shape no longer tells the full story. The cable has become a hidden specification sheet. The first layer is power. Some USB-C cables are designed for basic charging. Some can carry much higher power for laptops. Modern USB power delivery can reach up to 240 watts when the device charger and cable all support it. But the cable has to be built for that. This is where eMaca chips matter. Higher capability UCG cables can include an electronic marker that tells the charger and device what the cable can safely handle. Without that communication, the system may limit power. That is good for safety, but it also means the cable is no longer just copper and plastic. The second layer is data speed. This is where the confusion gets worse. A USB-C cable can be physically USB-C and still only support old USB 2-node data speeds. That is about 480 megabits per second. Another USB-C cable can support 10, 20, or 40 gigabits per second. Future and premium versions can go even higher. This is why your phone may charge with a cable, but your external SAD crawls. The cable did not fail. It did exactly what it was built to do. The problem is that the outside of the cable did not clearly tell you what it was built to do. The third layer is video. Some USB-C ports and cables can carry DisplayPort signals to monitors. Some docks can run multiple displays. Some cables are great for charging but useless for video. Again, the plug looks the same. The capability is hidden. Now add Thunderbolt. Thunderbolt uses the USB-C connector, but Thunderbolt is not the same thing as USB-C. A Thunderbolt cable may look like a USB-C cable, and many Thunderbolt ports can also handle USB-C devices. But Thunderbolt has its own certification, logo, bandwidth expectations, and feature set. Apple's support pages show this complexity clearly. Mac computers may have USB-C, Thunderbolt 3, Thunderbolt USB 4, Thunderbolt 4, or Thunderbolt 5 ports. A cable may charge, transfer data, or connect displays depending on the device and the cable. That sentence alone explains why ordinary shoppers are confused. The USB Implementers Forum has tried to fix the problem with clearer logos. Instead of expecting people to decode names like USB 3 Gen 2x2, the newer branding focuses on speed and power. 20 gigabits, 40 gigabits, 60 watts, 220 watts. That is much better, but it only helps if the cable is certified, labeled, and the buyer knows to look. In 2006, USB, if cable logo guidance goes even further. Certified USB to USB cables are supposed to be labeled with the appropriate data rate and power wattage logo. The idea is simple. The cable should tell you what it can do. The problem is that the world already contains millions of unmarked cables. Then there is the European Union's Common Charger Rule. From 28 December 2024, many new devices sold in the EU must use USB-C for wired charging. Laptops are scheduled to follow from 28 April 26. This is a huge step towards simplicity. It reduces port chaos and electronic waste. The rule also shows something important about regulation. Governments can force the outside shape to become simpler. They can push manufacturers toward a common charging port and clearer fast charging behavior. But they cannot make every consumer use case identical, because a phone, a gaming handheld, a monitor, and a professional dock do not need the same cable. But the U rule does not magically make every cable identical. It standardizes the charging port and pushes compatible fast charging, but a cable can still differ in speed, display support, length, certification, and power rating. The port can be common, while the cable remains specialized. This is the core paradox of UCC. It succeeded so well that it became the container for everything. Phone charging, laptop power, external storage, monitors, docks, audio, cameras, tablets, handheld consoles. The more jobs it absorbed, the harder it became for one cable to mean one thing. There is also a physical reason. High-speed cables are harder to build. They may need better shielding, tighter tolerances, active components, and shorter lengths. A cheap charging cable can be long and flexible. A high-speed US4 or Thunderbolt cable may cost more because signal integrity becomes harder at high bandwidth. This is why length matters more than people expect. At low speed, a cable can be forgiving. At high speed, every centimeter becomes part of the engineering problem. The signal has to arrive cleanly, without too much noise, loss, or interference. That is why some very fast cables are short, stiff, or expensive. Some cables are passive. They simply carry signals through carefully designed wires. Others can be active, using electronics to help maintain signal quality over distance. That can be useful, but it adds cost and another layer of compatibility. Again, the connector shape does not reveal the whole story. So the cheapest USB-C cable on a marketplace is usually not the best cable for every job. It may charge a phone perfectly. It may be terrible for a laptop display or SSD. The price is often not just brand markup. It can reflect real engineering differences, though bad labeling makes that hard to see. The practical solution is not to memorize every UZIB name. It is to shop by use case. For phone charging, check wattage. For laptop charging, check 60W or 2050W support. For fast storage, check data speed. For monitors, check display support. For Thunderbolt docks, look for Thunderbolt certification. This is also why official logos matter more than brand promises. A cable that clearly says 240W tells you something useful about power. A cable that clearly says 40WWW tells you something useful about data. A Thunderbolt logo tells you something different again. The fewer numbers you can see, the more assumptions you are making. And if a cable has no markings at all, treat it like a mystery cable. Use it for low-risk charging, but do not assume it can handle your laptop, external drive, or display. The cable drawer is not a library. It is a pile of unknown specifications. The best habit is boring but powerful. Label your important cables. Keep one known laptop charging cable. Keep one known high-speed data cable. Keep one known display or Thunderbolt cable. Suddenly, the drawer stops being a guessing game. The standard may be confusing, but your setup does not have to be. This does not mean UCBC failed. In many ways, it won. It put one connector on more devices than almost any port before it. It made charging simpler. It pushed companies toward common standards. It reduced the number of weird proprietary cables in daily life. But the final lesson is that a universal connector is not the same as a universal cable. UCC solved the shape problem. It did not erase physics, bandwidth, power, video, certification, or marketing. The plug became simple. The world behind the plug stayed complicated. So the next time a USB-C cable does not do what you expected, the problem may not be your laptop, your charger, or your monitor. It may be that the cable was never designed for that job. USB-C gave us one port. It did not give us one meaning.